So Consumers Union designed an experiment to test whether, from what I just said earlier, if I say we're doing an experiment, what am I looking for in the problem? Based off something I said when I was going over the homework. That should tell us that it's random what? Assignment, because it's an experiment. To test whether nitrogen-filled tires would maintain pressure better than air-filled tires. They obtained 2 tires from each of several brands. Oh, I just copied the wrong one. Okay. So softball versus baseball one. Well, now I feel better about some of your numbers. I just did the other one. Okay. Can students throw a baseball further than a softball? The one thing I don't like about what I did with both these problems, which is your homework, and this one is, so this one says this, which means it's going to be what? What does this tell me? So it's going to be a one tail. The one that I just started reading, that was not the problem you're doing. We want to figure out if air-filled tires lose more pressure on average. So what's that going to be? So I have them, I accidentally did them to where they're both the same after I typed them all up and then I looked at it, but I don't think that should be a big deal. So this one I have set up specifically to make it look like it is not a matched pairs. So like I made this one as non-obvious as like worst case scenario here. There is nothing in that chart that tells me that they are paired and that there is a reason to pair them together. Most of the time when you get a matched pair, there's going to be some kind of indication where it says like another line that says differences, or it says something up top like student number, pair number, something like that. So the question you have to ask yourself on a test is there a reason for me to do this? Like both of those go together, or does it not matter? So obviously we're just in matched pairs right now, so it's a whole lot easier. The answer is yes, there's a reason to do that, but why? They're both from one student. So I made this one as less obvious as possible, but technically this could be like student number. This is the first student, this is the second student, and so forth. And that's kind of the thought process you have to use when you're going through these. So that just tells us that it's matched pair. So let's start from the beginning. What's our state? We need to do what? What does it start with? First 3 words? The true mean difference in what? So I'll just say distance A student, and I'll bring that back in. Distance A student, what? And I'm put baseball or softball. What needs to be included at some point? So which would be the smartest way to set up this problem? And then I'm finishing out. So the true mean difference in distance a student can throw a baseball or softball. What else do I need? In yards from this high school. Did I miss anything? I think so. Okay. Am I doing a test or an interval? What tells me that it's a test? Is there evidence? And it doesn't give you a what? It doesn't give you a confidence level. That's a big hint there. So is there evidence that, so we're going to test. So if we're going to test, we don't write we want to estimate. We always do what here in a test? So null hypothesis is going to be what? And then our alternative, and that is specific because I chose baseball minus softball, would be mu D what? If someone happened to say softball minus baseball, what's the only thing here that would change? It would just be less than. So. And then what else?
Also at separate, it had 24 lines of the students, but that one has 15.
Oh, I started typing the problem and I didn't feel like typing all 24. I just took the first 15. I'm glad you said that though. What he said is the problem said, I was doing this when I was still at school at like 6 o'clock and I didn't feel like doing it anymore. It says 24 right here, and you might want to make a note of that. I only put 15 in the sample, so don't let that mess you up.
So it's 15.
It should be 15. I just typed it as 24 and then designed that by line. And then so what else should go here? And did this one give us an alpha? So we're going to use what? So interval we want to estimate, test, null and alternative. First part of plan is what? And this is a so of that entire thing, the only thing that changed from yesterday to today is what? It was the interval analysis test. Random. What about I go backwards time-wise? Let's skip to do and then come back to that as far as me checking it. Because it looks like a lot of y'all got to do and started looking around. So I've got, in my calculator, what would I have done in this problem? Put what where? Put baseball on list 1 and then softball on list 2 and then gone to list 3 and then did what? List 1 minus list 2. So when I'm actually, what are the things that I'm going to need without numbers? All right, so I'm definitely going to need those. There's no reason to go do one variable stats because our test is going to do it for us. Let's go ahead and write our generic equation. And you can write 0 or number. I don't really care because technically it could be something else. Divided by. So I write all of that first because my calculator is going to do all of it for me at once. So I'm going to basically have my blanks to fill in and then go fill them all in at once. So when I go to stat tests, where do I go? Is it 1 or 2? 1. Is it proportion or not proportion? Not proportion. Is it a test or an interval? Test. Is it Z or T? So our only possible option is 2, which is T test. Data or stats? Data, because we've got it already typed in a list. Now there's something there that we've never seen before. We know that in our list is which list? L3, but it has a mu naught in there. We didn't write a mu naught anywhere. But where does mu naught, like does something not usually come from? Like where have I usually written the null hypothesis? And what number did I plug in? 0. So you plug in 0 there. Light bulb. Anybody got it? Not like real light bulb. Which one did we choose? Not equal, less than, greater than? Greater than. Nobody's asked, but draw just actually like draws the graph for you out. It's kind of pointless. So calculate. So it gives me all of these all at once. My X bar is 7.9333. My S is 5.5222. Oh, I did this other order. And my N is 15. And this, with my numbers plugged in, gives me 5.5222. 0.564. If I round it to 3 decimals to t. I have this, now what do I do with that? So that is a positive number, so it goes on the right side. I'm shading which way? To the right, so we do greater than as our alternative. And it gives me my p-value of 4.035. So 3.4896 times e to the negative 5. So you move it over 5 spaces, which puts 4 zeros in front. And that is my p-value. And I'm comparing my p-value to what? Which is what is this? This is a very small number. This p-value is a very small number. So what is that saying? A little bit of evidence or a lot of evidence? I've never talked about it this way. A lot of evidence. Does that make sense? We have a lot of evidence. People can throw a baseball farther than a softball. Yes, because baseball is smaller. So not writing I'm going to say our conclusion, then go back to actually write stuff with the conditions. Our conclusion would just be, we what? Well, let's go ahead and write this. It's really easy. We reject, what do we reject? That presents which means we that what? Which is, and that's all you have to write for your conclusion.
Could you write, you do have convincing evidence that students similarly use baseball players?
Yep. You can always go with the exact wording in the problem or just put it in words, yes. And a lot of times I'll do my answer, like my answer key is like both. Just because some people do one and some people do the other. I don't care either way. Now, why is the reason that I can write that so generic? Because I defined it so well in the first place. So let's skip back to plan, and I'm going to talk through it to make sure that we cover it all. So random here is what? The order in which they threw which one, which, kind of thinking through it, that might make a difference. You might hurt your shoulder when you throw the first one as far as you can, and the other one doesn't go as far or something like that. So we want there to be no confounding. What's my next condition? So it's the order at which they threw each. Which one they threw first, which one they threw second. That's random assignment. You need to explicitly mention baseball and softball in that. People are saying randomly assigned this and didn't say it in context for the quiz. I'm not going to make you say both if there are both, but then that goes to the generalization thing. That's why I'm trying to avoid the ones that don't say random assignment. You could write both if you wanted to, though. But it's kind of more like, what do I do with my results, not are these right? All right, so normal, what do I have to do? Histogram of values. This one looks pretty good, doesn't it? If you tweak this one a little bit, I think it looks like really, really good. It doesn't take much to tweak it to look really symmetrical. You don't have to tweak it, that's fine, but we'll make a histogram of what? Differences. So make sure your title of the graph is histogram of differences. And make sure you have numbers on the bottom that go in between the bars.
And, do you care, when we label it, most of the time it's like a negative and a positive?
Oh, okay. So what was that weird bar thing in the middle of your graph? Yeah, it was 0 was that big bar line. So you don't have to draw that if you don't want to, though. So like, when you did this one, the way the graph made it, I don't know, what was the first number here? And then what was the next one? So there was this black bar that went through here, telling you that that was 0. I can make this graph without that bar in there. That's just the graph, the axis in your calculator cannot be removed, which is helpful so that you realize it's there, but you don't have to draw your graph that way. And you can, or you don't have to, but you can just draw it straight like this, like usual. And then so I check the graph for what? No strong skew, no extreme outliers. Now the thing with the axis number, have we dealt with that like at all before? I don't remember any problems that we've seen that come up with it. Should we see that much now? Yes, because we're dealing with values that are about 0 and maybe on both sides of it. So with paired, you see it a lot more often than with anything else. No strong skew, no extreme outliers, so we can use normal approximation. Our 10% condition, independent 10% condition, we start out with 15. So assuming there are at least what? 150 students at this large high school that could have thrown each or something like that. Questions?